Imagine you're at home minding your own business, when suddenly the ground begins to shake with an earth-shattering rumble. You cautiously peer out the window and see that the familiar landscape has been replaced by a massive towering cloud of ash and smoke blotting out the sun. In the distance, you can see what looks like a new lake where there wasn't one before. Your worst fears are confirmed as a panicked newscaster on the TV announces that a nearby volcano has just erupted, and it's big, really big. In fact, it's a supervolcanic eruption, one of the largest the world has ever seen. And while you hope that you and your family will be okay, you know that the whole world will never be the same again. You might think such a disaster is thankfully only relegated to the realm of fantasy, but in reality, these super eruptions have happened many times throughout history, and they could happen again. So here's how they occur, and what you need to do to survive one. The first thing we should clarify is exactly what we mean when we use the term supervolcano. Volcanoes are rated based on their height, or more specifically, the height of their vertical columns of smoke and ash. Officially, any volcano that erupts to an altitude of over 33 kilometers or 20 miles is considered supervolcanic. However, scientists reserve the term supervolcano for any volcano that erupts to an altitude of over 65 kilometers or 40 miles. By this definition, there have only been a handful of super eruptions in Earth's history, but there are many other volcanoes which are capable of similar eruptions. These include Yellowstone, New Zealand's White Island, Mount Vesuvius, and even the relatively small but mighty Mount St. Noggins in Japan. And experts believe there are probably hundreds more out there that haven't yet been discovered. But what makes some volcanoes so much larger than others? It all has to do with the magma found beneath them. Magma is molten rock found beneath the Earth's surface, and depending on its composition, it can contain varying amounts of gas. The more gas present, the more explosive a volcano can be. This is because as the gas-filled magma ascends toward the surface, the pressure and temperature decrease, which causes the dissolved gases to expand and form bubbles. If these bubbles are unable to escape, the pressure inside the magma chamber will eventually rise to a critical point, and the result will be a violent explosion. Meanwhile, the silica content of the magma determines how viscous or thick it is. The higher the silica content, the thicker the magma, and the lower its gas content, which means less explosive potential. With this in mind, you might think that the perfect recipe for a super eruption would be a low silica content and lots of gas, but that's not the case. As it turns out, the majority of Earth's super eruptions have actually been caused by magma with a high silica content. This is because most of the world's supervolcanoes are actually caldera-forming volcanoes. A caldera is a large, roughly circular depression that forms when an underground magma chamber gets emptied during an eruption. As the magma chamber gets drained, the ground above it collapses into the void, forming a caldera. Now, caldera-forming volcanoes aren't all that different from your typical stratovolcano, except that they're way bigger. Instead of being formed by layers of lava and ash, caldera-forming volcanoes are formed by a single massive eruption. The reason why these extremely explosive eruptions are able to produce so much ash is because of the high silica content of the magma. Because silica is a highly viscous substance, it tends to trap gas bubbles near the top of the magma chamber. This means that when the trapped gas expands during an eruption, it can violently eject huge amounts of ash and pumice into the air. Take, for example, the Toba super-eruption in Indonesia, which is widely regarded as the largest known eruption in the past 2 million years. It was caused by a magma chamber that had been slowly filling up for centuries. Eventually, the pressure inside the chamber exceeded the strength of the surrounding rocks, and the result was a massive explosion. The eruption ejected an incredible 2,800 cubic kilometers of ash and pumice, which spread around the world and blocked out the sun for months. Some scientists even believe that the Toba super-eruption may have caused a temporary ice age. Caldera-forming eruptions can also pose a serious threat to anyone living nearby. During the 1980 Mount St. Helens eruption in Washington State, USA, an estimated 6,000 people had to be evacuated from the surrounding area. But despite the danger they pose, Caldera-forming eruptions are nothing compared to the true kings of explosiveness, the ultra-viscous, so-too-rich magma. Ultra-viscous magma contains so much silica that it's almost solid. However, if it manages to make its way to the surface, the results can be catastrophic. This type of magma creates extremely dangerous pyroclastic flows, consisting of hot ash and gas that move at a speed of up to 160 kilometers per hour and temperatures of over 1,000 degrees Celsius. One of the best examples of an ultra-viscous magma eruption was the 1510 AD eruption of Mount Unzen in Japan. Pyroclastic flows from the eruption destroyed everything in their path, killing over 15,000 people. Unfortunately, for those living near ultra-viscous magma volcanoes, there's very little warning for an eruption. This is because the magma is so thick that it doesn't create the telltale gas bubbles that typically precede an eruption. Now, if you're still watching this video, you're probably thinking about the possibility of a super eruption occurring soon. You may have heard some scientists predict that the next super eruption will take place at Yellowstone National Park in the next 600 years. But don't worry too much. It's very unlikely that you'll be affected by this or any other future super eruption. That's because even though there are hundreds of supervolcanoes on Earth, the chances of any one of them erupting at any given time is incredibly small. In fact, according to the US Geological Survey, the chance of a major eruption at Yellowstone is somewhere between 1 in 250,000 and 1 in 750,000. For comparison, you're 125 times more likely to be struck by lightning in your lifetime than to die in a supervolcanic eruption. However, should you find yourself in the unfortunate situation of being caught in one of these rare events, you should follow these 3 tips to survive. First, avoid the surrounding area. If you live within 100 kilometers of a supervolcano, you should keep a close eye on its activity. Most volcanoes will display signs of unrest before an eruption. This includes increased seismic activity, ground deformation, and elevated gas emissions. If you notice anything unusual, immediately evacuate the area, head to a pre-designated safe zone if possible, or get as far away from the volcano as you can. Second, protect your head. Once the eruption begins, you want to cover your head and mouth with whatever you have available. This will help protect you from inhaling ash. If you have a gas mask, put it on. Otherwise, try to seal your eyes tightly and crouch down to minimize the amount of ash that enters through your mouth. Finally, wait it out. After an initial explosion, there may be several smaller eruptions. Stay in your shelter until authorities deem it safe to come out, then begin to assess the damage. So while there's no need to panic about a super eruption happening tomorrow, it's always smart to be prepared. Keep a 72-hour emergency kit in your home that includes food, water, and a battery-powered radio. Also check in with your local authorities to find out what your community's plan is in the event of a nearby volcanic eruption. Remember, while a super eruption could seriously disrupt your life, it's not the end of the world. Now watch. Do you know what's inside the Earth's core? Or check out this video instead.